Welcome to part 2 in our cryptography mathematics series. So last week we began to look at what cryptography is. We learned about what ciphers are, and then we looked at some basic, or the most basic way of encrypting a message, which was the Caesar cipher. So the Caesar cipher was involved around adjusting letters' numerical values by a single number. So adding on, let's say 5, for instance, to each letter, in order to encrypt your message so that it's a bit more safe for transport, especially back in the day when we needed to keep our messages safe. So this week we're moving on to a bit more of an advanced method for encrypting. And in particular, it's called symmetric cryptography, or it deals with encrypting methods that are symmetrical. Okay, and then that will lead into next week where we're looking at asymmetrical cryptography, or when the way that we encrypt messages isn't symmetrical, and that'll be a bit more challenging. So we need to first develop these basics. So I thought I'd just take you through what's included in this lesson and the way that I feel like you would be able to best utilize resources that I've made. So at the top here, there's just a watch, which will be this video that gets posted. We then have a quick little think activity. So I just want you to think back on what you did last week and some of the advantages and the disadvantages of using a Caesar cipher. So just put those in that table there. Then goes on and talks about the fact that we skipped one of Eddie Wu's lessons about one-time pad. So there's just a bit of a description there about what a one-time pad is. Okay, doesn't really differ much to the Caesar cipher, and is very rarely used. So wasn't really that important to look into. We then have Eddie Wu introducing symmetric cryptography in this video, which is great. So I particularly want you to take note of the symmetrical, how we can use symmetry to decode. So for instance, if we use addition, then the opposite of addition is subtraction, okay? And symmetry about the operations that we use in mathematics. We're then taken down to an activity, which is the affine cipher. Okay, so we're sort of taking the idea of the Caesar cipher and we're just making it a bit more complex. Okay, and this is where algebra will start to get involved. So here you can see the first example, or example 1 here. Okay, quite similar to the Caesar cipher in the fact that we are just adding 3 to the letter value of each, okay, and then coming up with our cipher text. That then branches over to example 2, this one here, where we're multiplying by 3, okay? So now we're looking at more complex methods or more complex math in order to decode our messages. So just work through these examples, have a look, and pay particular attention to how the numerical translation, okay, is then transformed by this, or by multiplying by 3, okay? And then there's a bit of a think down here where it's like, if we're multiplying 12 by 3, how is my transform number 10, okay? So just have a think about how that works. And take note of our modular that we used in the previous activity, or how, there's only 26 letters in the alphabet, so how can we account for the fact that we might actually get a number that's greater than 26? Great, well, this has moved a little bit. I have to fix this up, but I then would like you to complete the rest of this section here, okay, in the table below. So just fill out those values of transform numbers, which will tell me that you know how to do that confidently. Okay, so now I'll have to fix up this again because my writing here is all out of whack. So this is another activity where I'm asking you to multiply and add. So we're looking at building building operations on top of one another. Okay, so again, work through just in the previous examples. Okay, first identify the numerical translation, which you can use this table to help. All right, of each of these letters coming across. You then have to transform them by applying the operation. Okay, and then convert to the ciphertext. So let's say you got 2 in this box. Well, obviously 2 equals B. Okay. Now, there's another thing to read here, which just takes you through an example kind of what was happening in that previous activity. Okay, so it just takes you through the 4 steps that you would use to encrypt, or basically to apply our cipher. Okay, 1, 2, 3, and 4. Okay, have a read through that. Make sure you understand, and you might have to refer back to this in the coming activity. And then you are asked, in this activity, you're going to encipher the text, which is success is a journey, not a destination. Okay, so here I've included a few tables, and as you can see, I've got the letters for success is a journey, not a destination, coming down. Okay, so you're going to use the same process as before, except this time we're using algebra, or we're using this equation here to encrypt our messages. Okay, once you've done that, there's another activity here, and this activity basically is just to get you to think about, well, what is the problem with some of these keys? Okay, can we just have any key, or does it have to check out in the end? Okay, so again, follow through this activity here, and then write your concluding statement as to what the problem is with that key, and why we can't just use any key. Okay, and then also just have a think about all the possible keys that you could use then, if you now know which ones you can't. Okay, leading into the last activity, we have another read section. Okay, so now that we've learned how to encrypt using this affine cipher, okay, or using our algebraic equations, well, now we have to learn how to decrypt messages that have been encrypted using that method. Okay, so if someone sends us a message that they've used this affine cipher in, well, okay, now we need to decrypt it to understand what our friend says. Okay. So for this activity, it is quite challenging. I've included just underneath here a video of a walkthrough, okay, of how they went through that activity. So give that a watch, and you might have to re-watch it or reread this information up here again, the example, okay, before you attempt this next activity. Or if you attempt the activity but you're finding it challenging, okay, please just refer back to that video and this example. And hopefully that might give you an idea of where to start. Okay, I've got some text here to fix up again, but basically we're saying, or you're provided with a code, okay, and that code is along this line here. All right, it's a bit messy for that writing, sorry about that, but you need to decrypt that code. Okay, key things to note here is that this was the equation they used to encrypt it. Okay, so you're going to have to follow the process that we did in that last example to decrypt. And another key thing to note is that all these words have been put into blocks of 5 letters. Okay, that doesn't necessarily reflect where the spaces should be. So what you probably have to do is you'll probably have to put every letter together and then figure out where the spaces should be, or where the words are. Okay, it'll be pretty obvious once you've decrypted it where the spaces should be. And to make that activity a bit easier, what I've done here is I've said, well, hey, it'll probably be a good idea, before, seeing as this code is so long, or this encrypted message is so long, probably be a good idea to figure out the decryption of each letter separately before you try and decode the message. Okay, so using that equation that they provide up above, all right, decrypt the letter A. So A would be worth 1. Okay, so transform, once it's undone, or once you've undone its transformation, okay, put that number in the box. So let's say it was 5, okay, well, that means any A in that message above must actually be an E, okay, and go through and do that for each other letter. So let's say that was, it's another easy one, let's just say 3, okay, well, that's a C, okay, and once you've done that for each of the letters, then you can plug in your decoded message in here, okay, and hopefully we get a message that we can understand. And then the last activity, if we have time, okay, I'm not expecting you to get to this activity, but I thought it would be a great idea if you would come up with your own algebraic equation that you've used, okay, to decode to encrypt a message, and then send me that message and also the code that you use to encrypt it, and I'll do a similar process to what you did in this activity beforehand to try and decrypt your message, okay? So you can make it maybe a joke or anything, basically, anything that you feel like would be something that would challenge you to encrypt, okay? So yeah, so that's the end of the lesson. It is quite challenging in parts, so please refer back to examples or back to this video or back to any of the other videos throughout, okay? So yeah, happy coding.